Welcome back, pre-algebra. We're in lesson 44. We're going to talk about roots. But before I get into that, or I guess I need to prequel that, way back in lesson 16, we talked about exponents. And we learned that exponents were simply like when you have 2 times 2, that you could write that as 2 to the second power. Well, 2 is what we call a square. It is squared when we have 2 of the same exponent. And the reason for that is because of an actual square. We're referring to, well, that's just not a perfect square, is it? Let's see if I can change that. Maybe not. Let me redraw it. Let's see if I can do it right this time. All right, there we go. That's a perfect square. So if this were 2 inches by 2 inches, then that would be 4 1-inch squares in here. 1, 2, 3, 4, right? That is why we say this is 2 squared, because it's 2 by 2. It's referring to, or it's in reference to, area of a square. That's why we call it that, right? That's just your reference. But back when you learned your multiplication tables, we learned all of our squares. We know that 2 times 2, or 2 squared, is 4. We also learned 3 times 3, or 3 squared, is 9. 4 times 4, which is 4 squared, is 16. 5 times 5, which is 5 squared, is 25. And 6 times 6, you know, all of them. All the ones that we learned all the way through 12 times 12, this would be 36. And we know 12 times 12 is 12 squared, which is the same as 144, right? Remember your multiplication tables, because you are about to use every one of these squares. You need to go back and refresh your memory if you don't already remember these. When you see these numbers in what we're about to do, you need to have this memory set handy. It needs to be able to be called to your memory immediately. Let me tell you why. This is multiplication. And we've always said up to this point that the opposite or the inverse operation to multiplication is division. And that is true. But we have to look at division in a different way. We have to look at division as factoring. What numbers multiplied together give us this multiplied result? Right? What factors give us this? So division is more than just undoing multiplication. It's really factoring things out. So let me go on to show you how, or what I mean by that. Let's say I have 4 squared, which we know is 16, right? We can easily do that in our head. I'm going to introduce you to something called a radical symbol. A radical symbol by itself looks like this. It means, without any number here, it means by default that it wants the 2 factors. It wants you to factor out the 2 identical factors that equal this. So when you see this, the answer is going to be 4, because 4 times 4 gives you 16. So it's asking, the default number is 2, right? Just like the default sign is positive, we don't write it because it's the default. It's understood that there's a 2 here. So when you see this radical symbol, it's asking for the square root of 16. And we need to know those 2 times 2, 3 times 3, those square powers in order to solve these mentally. So the square root of 16 would be 4. The square root of 36 would be 6. The square root of 25 would be 5. The square root of 144 would be 12. You see where I'm going with this? This is asking you, this is the inverse operation, not to multiplication, but to exponents. right? Division is like factoring out. So are exponents. Only with exponents, here we have the square. With exponents, they are the identical factors. They have to match exactly. So there's another thing. This is the index. That's where the little number goes. You can have more than one identical factor. So for instance, if I were to ask for the fourth index of 16, or the fourth root of 16, then I would say, what is the factor that is used to multiply by itself 4 times? That would give me 16. So it's asking for x to the fourth is what it's asking for. What is that to the fourth up here that gives me 16? Or I should say what it's asking is 16 is equal to x to the fourth power. That's what it wants. It's asking for this. And so this, when you have this type of a problem, it's asking you to solve it by doing this right here. 4 and 4. So then this 4 cancels out and you have the fourth root of 16 is equal to x. So then the fourth root of 16, that's 2 times 2 times 2 times 2. Because 4 times 4 is 16. But we can split 4 into 2 times 2. So the answer to x, the fourth root of 16, is going to be 2 is the value of x, right? So I hope I haven't completely confused you. All you really need to remember is that the inverse operation to exponents, the inverse is roots. All right, and the inverse operation to roots, the inverse is exponents. All right, so I guess here's the way I want to write this. You have addition and subtraction are inverse operations. You have multiplication and division are inverse operations. But now you have exponents and roots are inverse operations. Okay, so those are the 3 main types of inverse operations that we have in algebra. And those are the ones that you're going to be using over and over and over again from now on to solve. And we haven't really been using a whole lot of exponents until now. Now we are going to start using exponents and roots interchangeably. So our first example problem is 44.1, and we have 4 problems. We have the fourth root of 81. We have to find that. Then we have the third root of 27. And we have the square root of 16. And then we have the third root of 8. And on Jupyter, whenever you have that algebra keyboard that comes up, there is a little key that looks like this, right? Basically, it looks like a big arrow. That is your shift key on your keyboard. That's really, really sad looking. Let me do this a little bit better. All right, so you have a little shift key like this, and it's kind of shaded in. If you would press this key, up here in the row above it, there's another key that normally looks like this, and it allows you, when you click it, it allows you to type a number in here to give this. When you hold the shift, when you click the shift key, you get a different key, and it has a little box right here. What that does, when you click this, it allows you to type a number in here, and then type a number in here, and then you hit the space bar and it comes out. Okay, so that's how you can get to the indexed root. And that should have been illustrated for you in your intro to pre-algebra, the very, very first lesson that we did that showed you how to use Jupyter. So if you forget how to do that, go back and do that intro to pre-algebra to remember. Go to the pod that shows you how to do the indexed root. Okay. All right, so let's solve these problems. We're looking for the fourth root of 81. So it is the number that gives us 81 when we multiply four identical factors together. So first let's do a factor tree on 81. That's what I like to do in order to solve for this. So 81 I know is 9 times 9. I know that in my head. It's a square. And it makes sense. If you know your squares, then you can multiply your squares to find fourth roots, right? 9 is 3 times 3. So that means that the fourth root of 81, 1, 2, 3, 4, the fourth root of 81 is equal to 3. Because we can say 3 times 3 times 3 times 3 to get 81. All right, written another way, 3/4 is equal to 81. 3 to the fourth power is equal to 81. All right, if you can do this with your answer to get back to the number inside the root, then you know you have the right factor. All right, this is the answer. So let's factor this one. All right, so 27. I'm looking for the three factors that are identical that give me 27. So let's factor it. I know that 27 is 9 times 3. And I know that 9 is 3 times 3. So I'll just bring this one down. So 1, 2, 3 identical factors that give me 27, right? So that means that the index, the third root of 27 is equal to 3. The way to check that is to say 3 to the power of 3, 3 times 3 times 3. If that is 27, if that is the number under here, and it is, then 3 is the correct answer. All right, so you can see how these are the inverse of one another. Here I'm breaking apart the answer into 3 factors. Here I'm taking 3 factors and multiplying them to get the answer under the root. All right, 16. I'm looking for, there's no number here, so that means I'm looking for the square of 16. So all I need to do is factor 16 into 2 identical factors, and we know what that is. We know that 4 times 4 is equal to 16. So that means the square root of 16 is equal to 4. And because I know that 4 squared, 4 times 4 is 16, that takes me back to that number here, then this is the right answer. This is me checking my work. Now I'm looking for the third root of 8. So I'm going to factor. I know that 2 times 2 times 2 is equal to 8. Those 3 factors, that matches the number that I need. So the third root of 8 is 2. If I can take 2 to the third power and get 8, which I can, 2 times 2 times 2 is 8, then I know that this is the right answer. Okay? If these two match, when you take this number and apply this index, if you get this value back, then you know you have the right factor. But if you can't take this factor and multiply it times itself this many times to get this answer, then you've got the wrong factor. Right? That's how you check your work. You take the index, put it on the factor, and multiply. It should come out to the same answer. That is how we check for that. Now, one of the things that you have to know, let me clear the page, is that any root of 1 is equal to 1 because 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 times 1 is still 1. So any root whatsoever with 1 here is 1. All right, so that is something to remember. So let me update our order of operations. So here's our updated order of operations. Exponents and roots come before multiplication and division, but after symbols of inclusion. So we look for the symbols of inclusion first. Then we look to simplify exponents and roots, and then we multiply and divide in order from left to right, and then we add and subtract in order from left to right. That is where we get what we call PEMDAS. And PEMDAS is parenthesis, exponents, multiplication, or I should say multiplication, division, addition, and subtraction. Now these are done together and these are done together. And you'll find that these go back and forth because sometimes you have exponents on the outside of parentheses. And that's when you have to take care of those kind of simultaneously. You have to look at them together. So we look for our symbols of inclusion first, and then we analyze to see what we need to do with our exponents, if we have any with the parentheses. And we'll get more into that as we go later. But for now, we're going to look inside the parentheses first, then we're going to look at our exponents and roots, then multiply and divide, then add and subtract. Those are our 4 steps of PEMDAS. All right, so let me clear the page. Make sure you write this down and update your notes. And let me go on to our last practice problem. So here we have 44.3. 4, we've got to simplify. 4 times 3 minus 2 plus 8 plus 2 squared, that's a 2, minus the cube root or the third root of 27 plus 12 divided by 2. That looks really hard. At first glance, you're like, oh my goodness, what am I going to do? But it's not that difficult. So again, we look for parentheses first. So here we have some parentheses. We have 4. Let's put our parentheses here. 3 minus 2 is 1 plus 8 is 9. So that's 9. Okay. Now we have plus 2 squared. We've done all our parentheses, so now we do our exponent. 2 squared, that's 2 times 2, that's 4. Minus the third root of 27. I know that 27 is 3 times 3 times 3. That is the third root of 27, so it's minus 3. Plus 12 divided by 2. Now all of my exponents are taken care of too. Now I need to go to multiplication. But Miss Tracy, you have parentheses here. I know, but there's nothing to do inside of the parentheses. The parentheses, when there's no operations within the parentheses, we move on and do the exponents next. Now this parenthesis just means multiplication. So it's really as if it is written like this. 4 times 9. That's really what that means. So 4 times 9 is going to be 36 plus 4 minus 3 plus, and we have 12 divided by 2. That's going to be 6. Now all we have left is addition and subtraction, and we do that in the order that it occurs. 36 plus 4 is 40 minus 3 plus 6. 40 minus 3 is going to be 37 plus 6. 37 plus 6 is equal to 43. And that is our final answer. Yay! And that is all we have for lesson 44. If you have any questions at all about roots, exponents, you can't quite wrap your mind around it, please ask me for help. I am always available. That doesn't mean I'm going to answer immediately, but you can always send me a message on Jupiter, and you can always text me if you have my number. But messaging me on Jupiter is available for everybody. Please message me. Please ask for help. Don't just suffer in silence. That's not healthy, okay? For anybody to suffer in silence whenever there is a problem, you should always ask for help, okay? We can't do it in this life all by ourselves. You can't figure this stuff out all by yourself if you don't understand it in the first place. If you understand it, that's fine. Go ahead and do your work by yourself. But if you don't know, ask. If you're struggling, ask. That being said, a little bit of struggle is important to the learning process. You know, you should take a minute and see if you can figure it out on your own first. But if what I have said in the lesson completely confused you, and you're like, I don't understand this at all, then reach out. I want you to understand and master the material. And I'm here for that. So message me and I will answer your messages in the order that I receive them. And that's all I have for lesson 44. I'll see you in lesson 45.